To the course of IPv6. So today we are going to discuss about the introduction to IPv6. So as in previous lecture we have discussed about the IPv4 addresses. So in this class we are going to discuss about the brief introduction to the IPv6. So in this class we will discuss about its feature of IPv6 and why we need this IPv6 addresses and its advantages. So starting with the first, that is IPv6. So what is IPv6? IPv6 are the network layer protocol that provides the identification and location of computers on network and routes the traffic across the internet. It means it works same as that the IPv4 addresses that are also used for giving the identification to the network addresses and network devices. Same way here IPv6 is used to give the identification and tracing the location of the devices over the network. So IPv6 is also introduced by IETF, that is Internet Engineering Task Force. So IPv6 is also known as IPNG, that is Internet Protocol Next Generation, and it is the most recent version of the Internet Protocol. So it was introduced to replace the widely used IPv4 address that is considered as the backbone of the modern Internet. So in 2004, Japan and Korea was first in public deployment of IPv6. So now we are using these IPv6 addresses in our devices and today's. Next is the features of IPv6. So the first feature of IPv6 is about the source and destination addresses. So it is 128-bit long. It means as in IPv4, the source and destination addresses are of 32-bit long. Here these addresses are of 128-bit long. Next one is the simplified address header by moving all unnecessary information. So by removing the unwanted information from the IPv4 header, we have made the IPv6 header simplified. So as in IPv4 header, we have discussed about lots of fields that are included in IPv4 header. But as in coming lecture we will discuss about the IPv6 header. We will see that IPv6 header is very simplified header, having very by removing all unwanted information that we don't want to use in the IPv6. Next part is it provides end-to-end connectivity. It means it is providing the IP addresses to each device in the network, and it makes the communication through the internet without using the net. So here we are not using the net technology. Here we are providing the every device in the internet with a particular IPv6 address. It is a faster forwarding routing due to the less detail at the header. As we have made the header part simpler, it will make the faster forwarding and routing communication in the IPv6 by using the IPv6 packets. It has IP security, which make it more secure than the IPv4. So in IPv6 address, we have added a new field of IP security. So it will add a more security to the IPv6 packet. And it uses multicast to communicate with the multiple hosts. So here we are using the multicast mode of addressing an IPv6, and it is used to communicate with the multiple hosts at the same time. So it here in IPv6 it doesn't support the broadcast addressing, whereas in IPv4 it supports the broadcasting addresses. But in IPv6 we will discuss about the unicast, multicast and anycast addresses. Next is anycast mode for packet routing is introduced. So there is a new part that is added over here, that is the anycast mode of addressing. We will discuss about this later on. So next it enables hosts to roam in different geographical area and remain connected to the same IP address. It means the same IP address our devices have a same IP address irrespective of the location. So if we are locating ourselves in the new geographical area, the IP address will remain same in IPv6 packet format. Next is it uses 6-bit DHCP and 2-bit ECN to provide better quality of service. It means here as in IPv4 we have used less number of bits for DSCP and ECN. So to enhance the quality of service information, here we have used the DSCP and ECN bits more, that is 6-bit DSCP, the differential service code point, and the ECN is the explicit congestion notification and it is of 2-bit. Then it supports smooth transition. It means transition from IPv4 to the IPv6 addresses. Like a source is using the IPv4 address and it wants to send the information to a device that is using the IPv6 address. So due to the combination of these IPv4 and IPv6, we have to make the smooth transition between these addresses. So here it supports the smooth transition. So these are the features of the IPv6. Next is why we need IPv6 IP addresses, as we have the IPv4 addresses, a lot of IPv4 addresses. So the reason being is to make communication possible, every device need a IP address to make it connected to the internet. So here the internet address system decided that IPv4 had a capacity of 4.2 billion addresses. As it has a larger capacity of 4/2 billion addresses, so the problem arises when the number of devices in the network increases. So as the number of devices in network increases, like a computer, smartphone, TV, smartwatches, cars, so these all are using the internet. Due to the evolution of Internet of Things, that IoT, due to which the increase in number of devices over the internet is increased. So these addresses are not enough to meet the demand of the new devices. So these 4.2 billion addresses not meet the demand of the enough number of new devices. So to meet the demand, to overcome the shortage of IPv4 addresses, many methods are used to prevent the depletion of these addresses. Like we have used the subnetting, where we make the subnet of the particular address, BLSM, NAT, and these methods are no longer able to provide IP addresses to the network for the future demand. So to make the future demand possible, we have used the IPv6 addresses. So here we have represent the numerical representation of these IPv4 and IPv6 address. As IPv4 addresses have 32-bit address, it means it has 2 raised to power 32 IP addresses, that equates to the 4.2 billion addresses. So to overcome the limitation of IPv4, we use the IPv6 addresses. So IPv6 addresses are 128-bit long. That means they are 4 times larger than the IPv4 addresses. So 2 raised to power 128 means the total IP addresses are 340 trillion IP addresses. So thus this is the reason with the deployment of IPv6 address. So this is the very big reason to deploy the IPv6 addresses in the network to meet the future demand. The next is the advantages of IPv6. So the advantages of IPv6, first one is the larger address space. It means as we are using 128-bit long source and destination addresses, that means it has a larger address space. Next one is better header format. Better header format means it as we have removed the unwanted information from the header, it make it simpler and better. Next is new additional option. New additional option, as we have used the IP security, the extension header. So these are the additional information that we added in the IPv6 packet. Next is allowance for the extension. As here in this we are using the extension header to add the additional information like hop by hop option, destination options, routing headers. So due to this provide of this extension header in the IPv6 packet, it make us to add the additional information if it required. Next is more security. So due to the adding of IP security field, and this it enhance the security of the IPv6 packet as compared to the IPv4 packet. So this is all about introduction to IPv6. Thank you.